Okay, so the final thing in A2 trigonometry is harmonic form. Now, this has always kind of confused me because I probably got it until a couple weeks ago. So basically it is about this formula kind of thing, r sine theta plus or minus alpha, or r cos theta minus or plus alpha. Basically, these are other ways of writing things like a cos theta plus b sine theta, or a cos theta minus b sine theta. And the plus or minus is, just from the last video about which one goes with which. So you may be wondering how on earth these are kind of related, and how you can get between them. So if we put them equal to each other, we can rewrite this just using the formulas from the last video. R multiplied by sine theta cos alpha plus cos theta sine alpha. That's all multiplied by r, so you can rewrite that as r sine theta cos alpha plus r cos theta sine alpha. Okay, and then this is equal to a sine theta plus b cos theta. Now, we know that because these are equal to each other, let's get a different colour, a sine theta has to be equal to the part in this with a sine theta. So you could write a sine theta is equal to r sine theta cos alpha. And because there is a sine theta on both sides, you can cancel them out. Divide through by sine theta on both sides, and you're left with a is equal to r cos alpha. Now you can go straight to that if you say I am finding the bits with sine theta on both sides and just going a equals r cos theta, or you can do that. We'll do the same on this side. We're saying that b cos theta, which is this bit here, is equal to this bit here, r cos theta sine alpha. And then because we have cos theta on both sides, they cancel, and you're left with b is equal to r sine alpha. Now, sine over cos equals tan, so that brings us down to only one trigonometry term. So how do we get sine and cos into tan? Well, r sine alpha, which equals b, divided by r cos alpha, which is a, is equal to, the r is going to cancel, sine over cos is tan, b over a is equal to b over a. And that's how you can work out tan alpha. So if you would type in tan to the minus 1 of b over a, and you would get your answer in degrees or radians. But then how on earth do you work out what r is? Well, for me, I usually like to sub tan a, or alpha really, back into this here. So it's a b, which we know b is going to be something, a number we know, is equal to r and sine, and then we know what this alpha is because you can work that out from this step. Sub that in. Or another handy thing is that r is equal to the square root of a squared plus b squared, and you can prove that using Pythagoras. I'm actually not the biggest fan of that because I think it's so much easier to find this and then sub that in rather than do all the algebra required to get you to the point of being able to do Pythagoras. It's just a little bit easier, I think, to do this. So let's do an example, because examples are the best way to learn. So here is the first question. We want to write 3 sine theta plus 4 cos theta in the form r sine theta plus alpha. So I like to do this first. Use the double angle, or the compound angle formula to get that. R sine theta cos alpha plus r cos theta sine alpha. And I'm aware that I said alpha and drew a theta there. Whoops. That should be an alpha. Okay. Then I know that this is equal to 3 sine theta plus 4 cos theta. So I'm going to look at sine theta first. Here is the sine theta, and here is the sine theta. So 3 sine theta is equal to r sine theta cos alpha. And if you're confused to why, that I'm not including that at all, it's because if there's a sine theta here, which has to be the same as the sine theta there, then if those two are going to be the same, that means that r cos alpha has to be equal to 3. The rest of it has to be equal to the rest of that one. Cancel it, sine 3 equals r cos alpha, sorry. Okay, now let's look at this side. We have 4 cos theta here, and this bit here, r cos theta sine alpha. So r cos theta sine alpha is equal to 4 cos theta. The cos thetas cancel out. R sine alpha is equal to 4. And now we can get what tan is equal to. So r sine alpha over r cos alpha is equal to 4 over 3. 4 over 3 is equal to tan alpha. That's because the r's will cancel out. Sine over cos is tan, 4 over 3. Which means that alpha, now I would type this into my calculator, it's possibly slightly easier. So ignore what I already have on the screen, let's get the calculator in view. So I'm going to say tan to the minus 1 of 4 over 3 is equal to 53.13 degrees. That is alpha. So alpha equals 53.13 degrees. Now, if I want to work out what r is, I know that r sine alpha, but we know what alpha is now, so r sine 53.13 equals 4. To get r, divide by sine of alpha. So if we get the calculator back, we're going to say that 4 divided by sine, answer, just to put the alpha straight in, we get 5. Let's write that here. R equals 5. But that's not finished. Remember that we want to write it in this form here. So your answer would be, this is equal to 5 sine theta minus, or plus, sorry, the plus up there, 53.13 degrees. And that is your answer. That is how you do these questions. You just have to equate and know how to equate them, and then they can be quite easy. Now, there's only one other type of question they can ask you about this, which is what we'll do next. Okay, so for the last question, it says 2 cos theta plus sine theta, work out max and min. Nothing else, but you can see that it's in the form a cos theta plus b sine theta, so we can rewrite this as either r sine theta plus alpha or r cos theta minus alpha, but I like to use sine because you don't have to worry about the sine. Sine. But no, you don't have to worry about changing this to minus depending on whether that's a plus or minus. It gets a bit confusing with cos. If you get to choose, sine is always the easier one to go for, I think, unless you really like cos. So we are going to write 2 cos theta plus sine theta, and we're going to expand this using the compound angle formula to r sine theta cos alpha plus r cos theta sine alpha. And then 2 cos theta, remember the cos will cancel out with the cos here, so is equal to r sine alpha. I explained that in one of the last examples. Then sine theta, there's a 1 in front of that obviously, r cos alpha, and obviously the sine theta and the sine theta will cancel. So now to get tan, we can divide the two. So r sine alpha, which is equal to 2, almost drew a theta after that, divided by 1 equals r cos alpha, and then we get that tan alpha is equal to 2. So that is quite nice there. Now we can work out what alpha is. Now this time it's going to be in radians, just for another example. So alpha is now equal to, whenever you put in tan to the minus 1 of 2, you get 1.107 radians. Remember, not in degrees, so I'm putting a little c. And to get r, I'm going to then type in, let's get the calculator up here. To get r, I'm going to say 1 divided by cos of 1.107 gives me 1.00001, that which I'm in degrees, that's the problem. I was slightly confused about that. I should be in radians if I'm working in radians. This gives us 2.235. Now if we had it exact, it would actually tell us that this is equal to root 5. Root 5 is 2.23, and just because we didn't have the entire of alpha in, obviously there's more decimal places, it would tell us that it's equal to root 5, which is there. So we know that r is equal to root 5, which means we can rewrite this in the form root 5 sine theta plus 1.107 radians. Now I'm just going to move this up to the top so that we can then work out the max and min. Okay, root 5 sine theta plus 1.107, and we want to work out the maximum and minimum. Now, what I'd like to do now is look at a graph. This is going to be the graph of sine. Sine starts at 0 and likes to go up and down like this. Drawn very badly by me, but there's 0, there's 1, there's minus 1. Let's just pretend that that is minus 1 there, and that is plus 1 up there, and this is going to be at 90 or pi over 2, and this is going to be pi here, and then 2 pi there, and then obviously 3 pi over 2. So there's our sine wave. We can see that sine theta is a maximum whenever, let me see, this is going to be our x-axis, whenever the x-axis or theta is equal to pi over 2. And we can also see that sine theta is a minimum, so maximum, the highest it goes, minimum whenever x or theta is equal to 3 pi over 2. And so now we want to work out how we get the maximum and minimum of this. So we also know that it is equal to 1, by the way, and is equal to minus 1 because that is what it is on the graph for sine theta. But we have a slightly different equation which will look kind of like a sine wave, except it might be higher, might be lower, might start at different places. So to get the maximum, I'm looking for sine theta plus 1.107 to be equal to 1, because that's the highest sine can go. And so that means that I want theta plus 1.107 to be equal to pi over 2. We worked out that pi over 2 is where sine is its biggest. And so to get that, theta is equal to pi over 2 minus 1.107. Theta is equal to 0.464. And whenever sine is 1, so whenever sine of this is 1, that means this entire bit here is 1, multiplied by root 5, the maximum value is equal to root 5. That's kind of nice. Then if we go to minimum, we don't have much room here. The minimum, so we want sine of theta plus 1.107 to be equal to minus 1, because that's the lowest that sine can go. And so theta plus 1.107, we want it to be equal to 3 pi over 2. And so you can then work out that theta is going to be equal to 3.605. Those are in radians. That's just 3 pi over 2 minus 1.107. And so the min value, if this is equal to minus 1, then this whole thing, root 5 times minus 1, is equal to minus root 5. And that is the last type of question you could really get on this stuff.